Heading towards energy-neutral treatment with mainstream Animatie. The Zeneralta demonstration process. First, the wastewater is collected in the urban sewer system, and from there, it is transported to the wastewater treatment plant. The first step in the treatment process is the removal of coarse material larger than 5 millimeters by passing the wastewater through screens. In this way, matters such as hairs, leaves, and tissues are removed. The next step of the process is the A stage, which stands for adsorption stage. In a tank, the wastewater is aerated and brought into contact with activated sludge. Ferric chloride is dosed to bind phosphates. Due to a low dissolved oxygen concentration and short water and sludge retention times in the A stage, the organic matter in the wastewater is adsorbed rather than oxidized by the activated sludge. From the A stage, the wastewater and activated sludge flow into the intermediate clarifier. Here, the sludge is separated from the water by sedimentation. Part of the sludge is returned to the treatment process, whilst the excess sludge is pumped to the sludge treatment plant. In the B stage, the wastewater is aerated again and brought into contact with activated sludge. Residual organic matter is broken down further. Nitrification also takes place. In the final clarifier, the B stage sludge is separated from the wastewater by sedimentation. Part of the sludge is returned to the treatment process, and the excess sludge is pumped to the sludge treatment plant. In the sludge treatment plant, the excess sludge from the wastewater treatment process is anaerobically digested. In this process, biogas is produced, which is converted into electricity and heat by a combined heat and power plant. The conventional treatment process has a high energy consumption due to the extensive aeration requirements. To tackle these disadvantages, Water Authority, Hollandse Delta, PAC, and STOWA started the demonstration project Zeneralta, which stands for Cost-Effective Nitrogen Removal from Wastewater with Low-Temperature Animatie. Animatie technology has already been applied successfully in the treatment of sludge reject liquors. These warm and high concentrated flows provide optimum conditions for the Animatie bacteria. A goal of the Zeneralta project is to demonstrate that the Animatie process can also be applied in the mainstream of a wastewater treatment plant at much lower temperatures and nitrogen concentrations. Feasibility studies on lab scale and at pilot scale have proven that this is indeed possible. The next step is to scale up the technology in a demonstration plant. This so-called Zeneralta demonstration installation has been built at the two-stage wastewater treatment plant Rotterdam-Ducaven in the Netherlands. In the mainstream Animatie process, the A stage of the process remains unchanged. In the B stage, the conventional activated sludge process is replaced by the Animatie process. A combination of ammonia oxidizing bacteria and Animatie bacteria can accomplish the total nitrogen removal in a single process step. The granular structure of the sludge allows separation from the treated wastewater to be accomplished in a smaller space. Water Authority, Hollandse Delta, PAC, and STOWA have confidence in the mainstream application of Animatie technology for nitrogen removal. If Animatie proves itself a successful technology, the wastewater can be treated more effectively and at lower energy consumption, thereby contributing towards a reduced environmental impact and a more sustainable society.